Hello viewers, today we will complete this chapter, work, energy and power. And so I'll just pick up some numerical problems from your textbook and also how to calculate it. And thus we'll complete the syllabus, we'll complete the lesson today itself. So the later question, Mamangi class the question number 1 of linear numerical. Sina text week question number 2 duni. Question number 2 is a player kicks a ball of mass 500 gram placed at the center of a football ground. Sanaro yemana football ground ki maya thamba mass 500 gram of football ma kawi hai. The ball leaps its feet with a speed of 4 meters per second. The man ball comes on the ball to my macong tadoga 4 meters per second. Young Saki, man called Ziggy. Hangizina, find the work done by the player on the ball. Adu the ball do player ki macong call with the ball to pirate sacramina, tabak the reason. Player to never, player to not force on putuiba. Player in force to not tabak do any Canada ball to the Adu tabak do cana to putu. The last part is does it equal to the kinetic energy of the ball as it leaps? Aduki player to not work done do Musagi ball kinetic energy do Aduga manabra hanging. Mana in the mana de or an answer to Peter. Senior questions. So what we have to do is firstly for any numerical calculations you read the questions very carefully, and after reading the questions you collect the information which are given in your questions for your calculations and then write it down one by one, and then you also find out which things is asked to be find out, and then also you write it down and then you can start your calculations by using appropriate formulas. Question na para question na kari piri ye to hana khangdoni question na piri sing nangi angko hona no masani madu hana phasana itho thamani question to par kanda hangi poto no no putu hai do kai no do mai itho ne adai di mari le na mai form na do itho calculation to do ne basina mai ya same step ade answer je how is given. So after reading the questions carefully we have the informations. What are the informations? Mass of the football no pithe itho je mass M 500 gram. Siki mass 500 grams. Gram is SI unit. Adi apoi SI unit to put ke doine ba. Adi SI unit di mass kilogram to on bina si kilogram da hana convert to biram. Kilogram to on ke di listing na yen tara maram di 1 kilogram is equal to 1000 gram. Aduna gram kilogram to on to ke tar di you have to divide by 1000. Then how much you will get? Half kilogram. So this is the mass of the football. Adi atai kari pire boldness hanroidi makhong thadom daida laiba mai velocity do habidi initial velocity do is bitre here. So the second one is initial velocity. Initial velocity of the ball. Ball ki initial velocity to niko symbol di u word ni cp2 4 meter per second. Meter per second is SI unit no brina conversion daga hoidre. Sigaisina angkasi hona ni mum ta ko the information sing dinu. That means these are informations given by the questions for our calculations. And then what we are going to find out, find the work done by the player to the ball. Koi dagar oidiba poto puthokto poto do ithosi require work done ma darka oireko work done by the player to the ball sima puthokko doiba symbol do li thamasi work done question mark thamasi puthokto poto ni tai ni ko. Last part of the question is Does it equal to the kinetic energy of the ball? Sigi work done siga ball ki kinetic energy to ga manabra hangin. The kinetic energy symbol se E ke thamage ko is equal to the work done. W. Simasu hangin. Ani sina kan puto doi. Adadi question se par kan da kari pithe kari puto ko no do make sen masa khai na khoi thame. Ado work done ka bai puto tara. Sig matang jida. Player do nani ko to odore ba thabak se Canada football do da. Ado sidai sida akhoi gi work done ni formula da sidai ngo work done hai se force ka displacement ga puinaba maneba si formula ni adige mo kinetic energy hai do E ke hai se half mv square maneba si formula ni hoi mari leina ba ada hojik jiki oina di khoi si tang chang adu atopa khangjan ga do mana work done hai se kinetic energy ke manan bi hai condition matung na kaino matam da gravitational potential energy ke manan bi hai ground gi nang na pot ma mathak ta na tha pagi work done do ado gravitational potential energy manai pot na leng de level nang lenghal laga kinetic energy lehlai do mai kinetic energy do pot de nang na taw ga thabuk tu manai sisu matang na tin ko sina do Sigi home civil relationship में दिनांग न condition खंग तदी माने इन हेक्ट लोक्शन बिया देखो मतंग ये अदु येंगस अदि आहान फॉर्मूला से नंग चेक तोरो सिगी मतिंग न पुथोके दि फोर्स लेगे दवनी डिस्प्लेसमेंट लेगे दवनी अदु क्वेश्चन जे दि फोर्स पिदे डिस्प्लेसमेंट पिदे अदि सिगी फॉर्मूला से पान बिया गदरा यार रोय we cannot use this first formula because we don't have the force and we don't have the displacement force and displacement so animal like we cannot find out work done by using formula number 1 adi kari upai to tare sida lagta re sigi work done puto bi atop upai se karma force ke displacement ke piram de adi force ka displacement ga pi da matam da khoina work done puto ke dar boi de pot ki kinetic energy le and da lekhala ba pot ki potential energy le and da lekhala ba adi energy ki mari na khoina lo bi ya adi hojik work done puto ke di work done do direct puto ya da na ai kari han puto tare kinetic energy han puto ni E case kinetic energy formula si formula number 2 the pire half mv square akhoi the kinetic energy puthoina hangde but still we need kinetic energy without this kinetic energy we cannot find out work done since we don't have force and displacement aduna ahan but first of all we have to find out kinetic energy now kinetic energy samne rege kedon ido je kinetic energy hain ko of the ball E ke na thamage formula में तुमने कराया E तारे half mv square si pan ने si formula number 2 जी ने कोई सी नहीं जी 1 सी नहीं half चलो माई value सिंग तो half ती half ले जरे mass तो half kilogram है बने सिंपल ले जरे माई velocity तो ना 4 नहीं velocity जी square लाखनी ना आई square दो स्माइन ना थमागे 4 नहीं थमागे कंगना में माइन ना सिगी टू सिगी कंगना किया रे को अभी क्या दंगे हो रहा है 4 लोअर मिन करी यूनिट थमनी हॉट लोअर मिन ना energy से कई दोन के joules तो ले work done joules तो ले अतने energy के work done के मानहन भी आ रही तो यूनिट चुदे ना माने joules अतो kinetic energy दी 4 joules होई तो ने अतो हॉट जो work done पुथो से अदि हौजिकी फुटबॉल तो हाना लेंगन लेरगा दि माइ वेलोसिटी 0 नि वेलोसिटी 0 नि किनेटिक एनर्जी अंत लेते को काउ जुमोइगा प्लेयर न काउ कांदा माइ वेलोसिटी तो डेवलप तोर काना माइ किनेटिक एनर्जी जे थोकलै नेबा अदि किनेटिक एनर्जी तो काना पिरे प्लेयर न कमाइ जो पिरिबा माइ यारे के एनर्जी दो पिसली नेबा अदि एनर्जी तो पिसल काना वर्क दन ओला काना वर्क तो तोर कांदा हौजिकी बॉल लेंगागा बॉल किनेटिक एनर्जी लेम तो लेलै नेबा अदि बॉल तो डेवलप तोरबा किनेटिक एनर्जी दो नुपा दना तोरबा वर्क दन तो लेगी ओलै नेबा adudi nupadana ball du kaw matamna toiba work done do ball du kinetic energy to mane adugi point du dik lawra ga si man laga answer se p doine ba. The next step this kinetic energy E K of the ball is developed due to the work done W by the player to the ball. Adi kinetic energy to the work done margam theko. Therefore, work done is equal to kinetic energy. Si margam theko. Adi apai E K di putho thameba. Adi value sinjalo sinata is a work done do karke mana tare E K ga mane E K do koin hoto thame force. Si apai answer ne. The player to na football to the third work then the 4 joules cut away to never. The last part of the question that thus the kinetic energy is equal to the work done have do. Sinadum pizeram. Last part of the answer. Work done is equal to kinetic energy. Ani maksha answer ne khan bya. Work done is equal to 4 joules. The work done to the kinetic energy to manabra is to mana and high bya. The nan sentence bin ivermi ai. Last part of the answer do. Yes. The kinetic energy of the ball is equal to the work done. W. Last part ke. Amu ito. Since my to the whole level numerical problems. Adan formula to khambiraba aduga work energy power and period me andagi idea do adana concept leraba adi numerical code base di arugu thoro natte mathan question ma mo yengase textbook tagi adi simuthalaje यहाँ मतलब क्वेश्चन है textbook की नंगी question number 3 दुनी question number 3 of your textbook question number 3 ने करे है a ball of mass 2 kilogram is thrown upwards vertically with a speed of 4.9 meter per second. 4.9 meter per second. Find the potential energy when it reaches the highest point. 한부터 보도록 아니시부터 보도록 calculate maximum height it reaches. Sini question to The question that I'm saying even minor can get together. A ball of mass 2 kg is thrown upwards vertically. Volume perpendicular something with a speed of 4.9 meter per second. My language speed to the initial velocity is man. Find the potential energy when it reaches the highest point. And the ball to Langhalamina, Kakalani, Manakabanga, maximum height of Laniva, the Hanakara, the young target next moment. And the maximum height of Labukanda, Yobukanda Labu, my potential energy to Kamu to wine. Second part is to calculate the maximum height it reaches. Manu say, maximum height of Adukayano, Adukuto. I said, figure something and a half another. Sina ground to hell as it. See object ball to hell as it. Ground is lang. Magi langhat pagi speed to pire 4.9 meter per second. U do 4.9 meter per second. Si yang lang padoy ba. Horen sum kaklani. Sibo ma kabang sidai di makata na ma kabang na sidai di tara don si aro yung point ni. Si gizes yobu matam na leiba magi final velocity do 0 or ni. Langhat pang jine a or si ma na kari ba mafam maximum height sina b or si. Adi sidai na sibo ki awang ba se. Ma na kami ba si awang ba se. Si maximum height से capital H थमने si क्या ना पुतो वो है कौन पुतो को तो इसे माना काबंग नंबर maximum height तो ground इन्हें सिबाओ की सीधे ही है ना काबंग सिबाओ कार होगा ये तार पे कम तो रहा हूँ अगर सी की maximum height से योगो का ना लेवे मांगी energy तो gravitation potential energy EP दो अदो हंग अभी अकोई तो हंगी ऊपर से अनी ने बा माना कागा तो maximum height ने maximum height to Yorokanda, have the B to Yorokanda level, my gravitation potential energy EP to any of the whole height. Beside, see Mamang, what you question the talk about Mina, see there's a question, Munaparmatanda. Now we have the informations and let us write those information as given. Given in information in the choosing mass of the ball. Let us use small m to represent mass of the ball. It is equal to 2 kg. Initial velocity of the ball. Let us use small u to represent its initial velocity. How much? It is 4.9 meter per second. Si gaisina given to ni hoi to pitoka aduga putoka do ba dakar posing ji among irase kai kano dakar hoi to se find the potential energies me lere maximum height me lere adu ai maximum height ana putok se symbol of capital H thamaji sima puthoni mathang da potential energy puthoi do potential energy when it reaches the maximum height. The symbol to na si thamaji si yani se photo photo the final velocity se question the p to so koi isana dum p re lai re ne long to ni ko final velocity se 0 hoi do adana sidai sidai su nang option bbi final velocity jo final given the velocity v thamasi 0 sigi je le lo do adu dikhalo nang kari upai to kari formula pa la puthok de ge gravitational potential energy puthok ke di sida yawra kan le gravitational potential energy puthok ke di potu ki mass ma sangani mass le re koi mass to kilogram ani ne pitho le re mass to hotra se 2 kilogram ne pitho le re adu my height sima koi le tre adu acceleration due to gravity di question the piro koi isana simpa pu do na dum sina ga do ne g gi value to adu horen da kar ma tung na sina do adu di sigi anga support matam da object la ka do ri do formula number 1 da gravitational potential energy formula ni mgh ke mane similar ani horen ski maximum height se puthong matam da initial velocity le re final velocity le re acceleration due to gravity the single na loi le re na khalam ni na khoina ski formula se horen sina kani motion sector ja ho b square minus u square is equal to 2gh motion dana h ki muhta s ne represent over g muhta a ne represent over samani g se acceleration makalam ni small on hopani h is displacement makalam ni sina matham akhara sakpa surface salagna distance s ne represent over matham akhada le na height ne represent over displacement ni loi de samana matham mutung ni small on hopa sisu acceleration ni surface yoga a thamba matham akhagi yoga na gravitational force torque yoga na acceleration due to gravity ni g ne thamba si formula si so chang kani adoi sigi ani su formula si sinarga v0 lo gare u si the period lai re 2 number ni z simpa pu gi si question break to so ni simpa pu ri option ga do ni adi si lai re si chum nei ma sing ni g ju lai i pu thok ki si formula se pa dum ta la adi hoi formula se pan jang se aduga sidai nang nang bon matam da mathak ta smaina ka gi acceleration minus mathak ta langali ba velocity do minus makha da tara gana plus adu madi ka ya te adi apoi no sai sidai logi u equal to 4.9 is a numerical khatane horen anka holom tam da mai proper sign tham ni proper sign da minus tham bi lo ji yango by the formula b square minus u square is equal to 2g h to apoi capital h ne thamas apoi sida di capital h ne represent over adana capital h ne thamas adi kari la pu yare sida di c 0 square ni c gi si u square do u do apoi kya log tara 4.9 minus some hapo mathak langkhat ki be ni na c square am thamo musai sida ju habo bu yare musai apoi na given the e matam ju minus habo bu yare equal to 2 lai ra g value se langkhat po ita ga di mas minus lor ni 9.8 h di khang de nu puthok po to ni spine tham bi ni adi hosi kai tar ni si gi sima idras yare si minus am lai jani manung gi minus square la ni ma mang ni adu di some 4.9 jani smine thamaga sin minus thamaga yare somna kanda si minus se thambiro purina pagi 2 into 9.8 h sin la ni ba na kanani gi minus mangna gi yare adi h pu thoki ri kamai lagta ra h equal to 2 into 9.8 mathaktana 4.9 into 4.9 kathana ta 4.9 into 4.9 divided by 2 into 9.8 kathana kana nang se kya phangade ge da 1.225 loirami na meter hang thambi si maximum height to ne wasai object na ball na kakhat khiba man ka ba maximum height adi value ne 1.225 adi apoi object maximum height se lai re ko sima loire si kanai mateng nu puthoi si the pd ba ni so formula se nu puthokani ba motion sector de yaw to adi object walo ri se kari no hoi walo ri se potential energy when it reaches the maximum height. Maximum height you can label my potential energy to put away. Adi hoji potential energy formula number 1 sinata EP to mass ka acceleration due to gravity ka sidai the man ka height to oren capital H on whole at the position adum loy ado di second part of your question ki answer is sidai is now potential energy of the ball when it reaches the maximum height is given by EP ne thambiro M ne Z ne H ne maram de khoi height to capital H ne represent tawrabina value sinjalo mai jo MD 2 kg ne 2 thamani GD 9.8 HT akhoi ji puthogi matun H to 1.225 and sigi matang the G value se akhoi minus hatra se are maram de khoi puthogi energy plus minus have a chiron. What we are going to do is we have to solve only the numerical value to cut can avoid to you. Other among the plus minus from the top, other minor. See position at that. See what Mutalazi? So now by using this relations for gravitational potential energy EP is equal to mgh, we are writing the formula here, but the sense is we sense this small h by capital H, because in our case the maximum height is represented by capital H, and then you put the values of m is equal to 2 kg, G is equal to 9.9 meter per second square into height means maximum height will already work it out 1.225 put it as C kissing say positioner kana nang na kya pangati ke da 24.01 lower mina you need to have in results and smile sin magi da ka energy to ne smile to put here ma ta ni ko adana what ma tam da question mun na pa ba question pa ka sin pi sin ka hani thok da ba kari put thok da mun ai tho thang da ba adu lower kan da Dakar Leba, Marie Lena, from Lasingo, working column that Tamaga, Yenga, the Chan from the power. What can we do? The Matan question about the question. Matangisina, question Krakalage, walk board in a Zimatanga, Matangoche. Question number 6. You mutapeare. Atai lemori ba follow the questions in do no in yumda homework ina follow and lockdown lo ekanda no homework ki book to sector kanda lamba sum du yenga se the questions e to se question number 6 text book after Tomba does 200 joule of work in 10 seconds, and his brother Pisak does 100 joule of work in 4 seconds. Sidahang is a question. Who is delivering more power. And this question now. Find the ratio of the powers of Tomba to that of Pisak. See the question. Honestly, the height is Tomba does 200 joules of walk in 10 seconds. Tomba has a mission of 200 joules of walk in 10 seconds. While his brother, the Amaram the Magi, Manau, Pisak Habzina, does 100 joules of walk in 4 seconds. Pisagna 100 joules of walk in second Marida. Pangtokado. Adi Moina Tokatao Pire, Toxing the Pangtomatam, the Sangimatam, Noina Pireko. Hangibu question Jahamada. Who is delivering more power? Adi Kanana power and Pibagi. Kanana power and Pibagi have said Kanan and power Saudi. Tomana power Saura, Pisana Saura, Hangi. Adi Animaki power to Tia Roiko, power so Pisaki Matu and Sarpir. Ani Subda Hangizina, Mabani power ratio to Putoi, Tomagi power, Pisaki power, Aniga, Tombagi power, Pisaki power, any ratio to Putoi. In the second part of the question. And this is mine put Patara. Answer Misak any Subanina, which minor policy. Kadang hot base system to Matang Matuna Hong Doctor, Tombayan policy, Port Tomba. Tomana Toigo work them done. $200. See what then it over the summer of the pitway. Second Jasang second Tara. My power was. Therefore, power of Tomba. Tombai power P has the Tomba Tapageko, Tombai Nekananaba. Tomana Turbo walked under the walked on the top of the Sangba, Matamani and Manani Sikrai the line of the Koi Pomla the line, or Pomla. Or I have to say, walked on the time, and you don't know. Karamatanda walked into later than energy and energy time. Because we walked the leg, walked in the yellow, energy leg, energy the yellow, smile. Adi Tomi Porputose walked into Caneva 200. Time taken a caneva 10. At the Captain Adicatare 20. You need to get a penny power, you need to assign what cover. Sin. Question 1000. Tombagi power said 21 point. Matanga, my brother Pisakium policy. Pisak is a work done period. Can my work done though? 100 joules. See 100 joules of work set over the sum of Matam's pitway 4 seconds. And my power to here. Therefore, power of Pisaki power of P Tamagas is the Pisak target. My Kanana school to Manatoriba walk to the my walk to the Sangmatan in Tokta 140 and that. At the Katan 25. So, equation number 2. Hello. So, now from equation number 1 and 2, we got the powers of Tomba and Pisak. The power of Tomba is 20 watts, whereas the power of Pisak is 25 watts. Then, who is delivering more power? Pisak is delivering more power. Because power of Pisak is larger or greater than that of Tomba. Tomba power in man here. Aditi, from equation 1 and 2, we have equation anish de koi kari phangeda P pisak is greater than P tomba. Then the first part of your answer, therefore, pisak is delivering more power than tomba. So the first part of your answer. Last part is loira sikhangalina mabani power ratio ku thobni tabudu ratio to kana loba tombagi power da pisaki power na lower ratio then ita last part ke do and tomi power iro minus samjalaji p tombai na dum thamaji is to p pisaka na dum samjalaji Pisaki power tomana lobanati tomi power pisanga loba habdina tomana hana irani tomi power matanga pisaki tomi power kya hoigra musai p tomado 20 watt is to amana 25 watt w is what is symbol si matang si nai je ada unit unit cancel tawna kini si masing ani is to cancel ratio loba si the symbol is to tamchi ratio is 20 to 25 yen mani DC 5 makeup, 5 4 are 20, 5 5 are 25. At the moment, I'm going to ratio to 4 is to 5. Senior, smile what the smile to the Sarapa, Kramaru, take 50 hour emergency though. We work out most of the important numerical problems that contains in the textbooks for this chapter. So in the next class, we'll start a new chapter from chemistry. For today, let's stop here.